Welcome to qnawire.
For this problem on the topic of quantum mechanics, we are told that a particle is in the ground level of a box extending from 0 to L. We want to find the probability of finding the particle in the region between 0 and L over 4. We want to then find the probability of finding the particle in the region L over 4 to L over 2, and we want to know how these results compare. We then want to add the probabilities calculated in A and B, and then we want to know if the results found in A, B, and D are consistent with the given figure. Now, the probability of finding the particle between x1 and x2 is the integral from x1 to x2 of psi squared dx. And for the ground state, we have psi1 to be the square root of 2 over L times the sine of pi x over L. And we have sine squared theta equal to a half into 1 minus cosine 2 theta. And so the integral of cosine alpha x dx is equal to 1 over alpha sine alpha x. So if we go to part A, we have 2 over L times the integral from 0 to L over 4 of sine squared pi x over L dx to be 2 over L times the integral from 0 to L over 4 of a half into 1 minus the cosine of 2 pi x over L dx, which is 1 over L into x minus L over 2 pi times the sine of 2 pi x over L, with x going from 0 to L over 4. And so this gives us 1 over 4 minus 1 over 2 pi, which is approximately 0.0908. So that's the probability of finding the particle between 0 and L over 4. Now, if we repeat the integral with limits of L over 4 and L over 2, so the integral of 2 over L going from L over 4 to L over 2, and this is the integral of 2 over L times sine squared of pi x over L dx, we find this to be 1 over 4 plus 1 over 2 pi using similar steps as above, and we get this probability to be 0.409. That's the probability of the particle being between L over 4 and L over 2. Now for part C, we want to sum these two probabilities, and rather for part C, we want to know how the results of A and B compare. So the particle is much more likely to be near the middle of the box than an edge. And for part D, we want to sum the two probabilities. If we add 0.409 and 0.0908, we get very nearly or exactly 1/2. Now, since the probability of the particle being anywhere in the box is unity, the probability of the particle being found between L over 2 and L is also 1/2. This means that the particle is as likely to be between 0 and L over 2 as it is to be between L over 2 and L. And lastly, we can see that these results are consistent with the figure that is provided. And this figure shows a greater probability near the center of the box. It also shows symmetry of ipsi squared about the center of the box.